In this video, we're going to look at method overloading examples that might occur in a program that we wrote on our own. So we've looked at an example in the Java API in the ArrayLists class where it uses method overloading, has two different methods that are both called add, and they can be distinguished from each other uniquely in our code by the way that we call the method. If we call the method with just one argument, it matches with the first version. If we call it with two arguments, an integer and an element to add, then it calls the second version of the add method. But this isn't just something fancy that happens in the standard library that like genius programmers can do. We can overload methods in our own classes. So we're going to look at a small example program that has two different methods in it. Both of them are called calculate. And you know what the purpose of the program is, that's not really important. We're just trying to think through, would we be able to declare both of these methods in our program? Would the compiler let us do that? So we have this first version of calculate. It takes an integer parameter and uses it to make some sort of calculation. It returns an integer as its data return value. Then we have the second version of the calculate method. They have the same name. The second version also takes an integer parameter, and this one returns a double data type, so it makes a different kind of calculation. What do you think? Do you think Java would let us compile our program with both of these calculate methods in there? No, it wouldn't let us do that, and that's because the signatures aren't unique. Only the return data type is unique. I have IntelliJ up here somewhere. Here it is, where we can look at the example code. You can see the red squiggly line there under my calculate method, and it says, hey, that's already defined in my main program that I'm writing, and so you can't do that. If the methods aren't unique, you'll get a method already defined error if you try to compile. I didn't even get that far. Let's go ahead and try to compile this program. Move it up so we can see our compile message. And you can see that it, it's mad about like what I've named my program. Sorry about that. All right, so I think it'll be happy about that part now. Let's try it again. So when we try to compile, it gives us an error message that says calculate int. So it's telling us the calculate method taking one parameter that's an integer is already defined, and so we can't redefine that. Let's look at a second example. This one's a little bit different. So this one has a main program in it, and it has three different calculate methods. I'm going to copy and paste this and dump it in my program over here. So the first question is, will this one compile? Are the signatures unique? Let's just look through it using our eyeballs first, and then I'll copy the code into Java. So we have the main method. It has three different method calls in there. This first version of the calculate method, it takes an integer as the parameter and has an integer return type. The second version of calculate takes a double as the parameter and returns a double as the return type. And then finally, the third version takes two parameters, an integer and a second integer, and it returns an integer as the return type. So what do you think? Do you think those method signatures are unique enough that Java would let us compile that program? Don't miss it. Oh. Okay, I got it all. So let's find out. Try building it. At the bottom of the screen, it tells me compilation was successful. That means, yes, this compiles. So these are three signatures. They're all different. This one takes one data type that's an integer. The second one takes a single parameter as well, but this time it takes a double. So Java will be able to tell the difference between method calls to those two items. And then finally, it has a third version that takes two arguments. There's two parameters there, so it'll definitely be able to tell the difference between that. Suppose that we were trying to call the method using the different versions up here. Just think through like which version would get called. So suppose we were calling calculate with 3. So in that case, it knows that this particular argument is an integer. So it's going to look for the version that has an integer data type. And it's just one parameter or one argument here. So it's looking for the version with one parameter. So that's the top version here. It has one parameter of type integer. That will match well with the version that has one argument of type integer. The second one, the one that takes a single argument 2.0, that'll get matched up with the second version because it's expecting a double. And then finally, this last version, it has 2 different arguments, so it'll get matched up with the version that requires 2 parameters. They're both integers, and in my program, in the example, they're both integers. So it matches them based on the data type. Everything's cool. And in fact, we could run this program. It'll give us our results. So it tells us data equals 4, 5, which is what's printing out. I'm sorry, it's like printed funny on my program. So it's printed data equals 3. That's the first method call. And then the second one is the one that says floating point data is 2.0. And then the last one, it's printing data equals 4.5. Usually it prints gobbledygook like this above this. I have to like look at this more carefully later on to figure out what it's talking about. I think it's just telling me about like which version of my compiler is getting used. So that's cool. You might wonder what's going on like in our program that we wrote. All of these different methods that we created, they all return a value, but you notice up here in the method calls, we didn't bother like saving that return value. And Java actually lets you compile even if you don't save the return value. It just doesn't help you do anything with that data value. So if we wanted to be more correct, we should probably call these methods by saying something like int result equals calculate with the data value 3, and then double result 2 equals calculate with the data value 2.0. And then finally, int result 3 equals calculate with the values 4 and 5. So that would allow us to save those return values, and we could like use them to print stuff out or make other calculations in our main program. That's a more precise way to do our method call. You might also wonder what would happen if we tried some other things. You can play around with this example code. So for example, if you wanted to know like what happens if I try to call calculate and I pass in 2 floating point values, like does that still work? And you can probably guess the answer by the red squigglies. No, that doesn't work. And when you hover over it, it tells you there's a calculate method that takes 2 integers, but that can't be applied to a method call using 2 doubles. So it tells you like, hey, I can't do that. If we fix it so that there was 2 different integer values there, then it would be all cool. So we've looked at an example program that uses method overloading. It just means that we have multiple methods in our code that all have the same identifier. You might wonder, why would somebody do that? Why would somebody write code where there's multiple methods that all have the same identifier? Well, it really makes a lot of sense. It's actually a really nice thing from a user perspective. If you're going to share your code with somebody else, and you have like multiple ways of performing like one logical operation in your code, like adding something to the array list, it's actually nice to call them both add and just have the computer be able to differentiate which version's being called based on the context in the program, because that's like less memory cycles for the person using your data type. You can imagine like if they had called this one like add to the end, and they called this one add a spot or an index or position or whatever, like it would be more trouble for us as users of the ArrayList class, because we'd have to remember like how did they spell that, what exact words did they use, how did they capitalize everything. It would just be a lot harder for us to use the class. It's a lot easier and more straightforward to have multiple methods that have the same name, and for us to just need to distinguish them based on the data type involved in processing that particular version of it. So method overloading might seem like a silly thing, like why would you name multiple methods the same thing? But it's actually something that helps with code reuse and with collaboration across lots of different programmers. Allows us to represent an idea in more than one algorithmic way, and for the computer to call the appropriate version based on the context in our code.